The forest is quiet, not silent, but subdued. Leaves shift low in the undergrowth, and somewhere deeper in the forest, something moves, slowly, deliberately, almost without sound. As night settles fully over the rainforest, something begins to emerge. A parrot, not flying overhead, but climbing, pulling itself slowly up through low branches before dropping back to the forest floor, heavy-bodied and unhurried. This is the Kākāpō, one of the strangest birds on earth. A parrot that does not fly, that moves at night and spends its life on the ground. At first glance, it seems almost contradictory, because parrots, as a group, are typically fast, intelligent, and highly mobile animals, built to move through forests, to forage widely, and to escape danger the moment it appears. The Kākāpō does none of those things, and for a long time, it looked like it was going to disappear entirely. But that isn't what makes the Kākāpō interesting, because the Kākāpō isn't a failure of evolution. In fact, it represents something much more interesting. It is what happens when evolution works perfectly, just not for the world it lives in today. To understand why the Kākāpō is the way it is, we need to step back and look at the environment it evolved in. This was a very different version of New Zealand from the one that exists today. For tens of millions of years, these islands existed in isolation. New Zealand broke off from other landmasses around 85 million years ago, leaving its fauna and flora to evolve independently for millennia. For perspective, in that time the dinosaurs went extinct, and most modern lineages of mammals and birds began to appear. In other words, it is a very long time. But more importantly, it is a long time spent without something that defines almost every other ecosystem on Earth: terrestrial mammals. The only mammals native to New Zealand are bats, alongside marine species such as seals and dolphins. There were no cats, no rats, no dogs, nothing moving through the undergrowth, tracking by scent. In their place, the dominant predators were birds: eagles, hawks, falcons, and owls. Large, powerful hunters that relied on vision and attacked from the air. And that matters, because when predation comes from above and is driven by sight, the rules of survival begin to change. Avoiding detection becomes more effective than fleeing, and stillness begins to outweigh speed. In some cases, even flight itself starts to lose its advantage. It's within this system that the Kākāpō evolved. It belongs to an ancient lineage of parrots found only in New Zealand, the superfamily Strigopoidea, which diverged early and followed its own evolutionary path in isolation. Today, that lineage is represented by just 3 species: the Kākāpō, the Kāka, and the kea. The Kākāpō branched off first, becoming the sole member of its own family, Strigopidae. The Kāka remained a forest bird, moving through the canopy and feeding on fruit, nectar, seeds, and insects. The kea is often described as an alpine specialist, but that description is incomplete. Today, it is most commonly found in mountainous environments, but this likely reflects a reduced range, shaped in part by human arrival and the loss of lowland habitats. Each species reflects a different response to the same environment. The Kāka in the forest canopy, the kea in open high-altitude environments, and the Kākāpō on the forest floor. But what makes the Kākāpō different? It followed a path the Kāka and kea did not, one that led it away from flight, away from daylight, and deeper into the undergrowth. Arguably, the Kākāpō is perhaps the best evolved to avoid the threats of that ancient New Zealand. It was a strategy built not on escaping from threats, but on avoiding them entirely. The Kākāpō represents one of the most extreme outcomes of that evolutionary pathway, where the pressure to avoid detection gradually reshaped every aspect of its biology. It is, today, the only flightless parrot in the world, and the heaviest of all parrots, as well as the only one to have become fully nocturnal. These traits, taken individually, are unusual enough. Taken together, they begin to form something more cohesive, a system built around a single principle: avoid detection. Flight is a useful place to begin, because in most birds it functions as a last line of defense. The moment danger appears, the response is immediate: take off, create distance, and remove yourself from the threat. But in an environment where predators already dominate the air, that logic begins to change. Taking flight does not guarantee safety. In fact, it may do the opposite, drawing attention in a way that stillness does not. Over time, the energetic cost of maintaining flight would have become harder to justify. Wings became smaller, the musculature reduced, and eventually, the capacity for powered flight was lost altogether. In its place came a different set of priorities: efficiency, energy storage, and a body built for life on the forest floor, rather than movement through the air. That same logic extends to reproduction. Most birds, particularly those vulnerable to predation, rely on vigilance or mobility to protect their nests. Kākāpō, by contrast, rely on concealment. Their nests are placed on the ground, often tucked beneath roots or within dense vegetation, where they are difficult to locate visually. Against predators that hunt by sight, this can be extremely effective. But it is a strategy that offers no redundancy. Once a nest is found, there are no secondary defenses, no speed, no aggression, no rapid escape. Behavior follows the same pattern. When threatened, many animals respond by fleeing, using movement to create distance and break the encounter. The Kākāpō does the opposite. It remains completely still, relying on its mottled plumage to blend into the surrounding vegetation and disrupt the outline of its body. Against an aerial predator scanning the forest below, this is a highly refined solution. Movement triggers detection. Remove the movement, and the predator may never register the animal at all. Even its reproductive cycle reflects the same broader strategy. Kākāpō do not breed frequently, instead timing reproduction to coincide with periods of resource abundance, particularly the irregular fruiting events of native trees such as rimu. In these years, when food is plentiful, individuals can invest the energy required to produce and raise offspring. In other years, reproduction simply does not occur. This is an efficient system, but it is also a slow one, and one that depends on environmental stability over long periods of time. Taken together, these traits form a coherent response to a very specific kind of world. A bird that avoids movement, avoids exposure, and avoids unnecessary energy expenditure wherever possible. Not because it is incapable of doing otherwise, but because within that system, it does not need to. The Kākāpō did not evolve to escape danger. It evolved in a world where escape was rarely necessary. And that is where the flaw begins to emerge, because every part of this system depends on the same underlying assumption, that predators hunt by sight, that they approach from above, and that avoiding detection is enough to survive. When that assumption holds, the system is effective, even elegant. But when it breaks, it does so completely. There is a commonly repeated account from early European explorers in New Zealand that you shake a tree and Kākāpō would fall out like apples. Whether this was ever literally true is difficult to know, but the sentiment behind it is clear. At one point, Kākāpō were not rare animals, nor were they confined to isolated refuges. They were widespread across much of New Zealand, occupying forests, moving through a landscape that had, for millions of years, been structured in their favour. In that world, their behaviour made sense, and their biology made sense. Each trait fit within a broader system that had remained stable over evolutionary time, where avoidance of detection was not just effective, but sufficient. That stability did not last. The arrival of humans marked the beginning of a shift, not just in species composition, but in the structure of the entire ecosystem. Early Māori hunted Kākāpō for food and feathers, while also altering large areas of forest using fire. Habitat became fragmented, and populations that had once been continuous were gradually reduced and divided. Even so, the most significant change was still to come. With European arrival came a fundamentally different type of predator, one that operated under an entirely different set of rules. Mammalian hunters, such as rats, cats, and mustelids, moved through the environment in ways that the Kākāpō had never encountered before, following scent rather than sight, and searching the forest floor systematically rather than scanning from above. This shift did not simply add a new threat. It changed the conditions under which every existing adaptation operated. Freezing, which had once reduced the chance of detection, now removed any possibility of escape. A behaviour that disrupted a visual search offered no defence against a predator capable of following scent directly to its source. Ground nesting followed the same pattern. What had once been an effective strategy of concealment became increasingly vulnerable, as nests were not only encountered, but actively located. Once found, they offered little resistance to predation. Flightlessness, too, took on a different meaning. Without the ability to leave the ground quickly, the range of possible responses to danger became extremely limited, and movement itself, slow and deliberate, provided little opportunity to create distance from a pursuing predator. Reproduction compounded the problem. The Kākāpō's strategy is built around low frequency but high investment, producing relatively few offspring and relying on stable conditions to ensure their survival. In isolation, this is not a weakness, but under sustained pressure, it becomes one. Losses accumulate faster than they can be replaced, and the population begins to decline in a way that is difficult to reverse. None of these traits failed in isolation. Each one remained internally consistent, still reflecting the conditions under which it had evolved. But together, they no longer formed a viable system. A strategy that depended on avoidance could not compensate once avoidance stopped working. As a result, decline was not gradual, it accelerated. Populations retreated into increasingly remote areas as the effects of predation and habitat loss spread across the country. On the North Island, Kākāpō disappeared first, with populations gone by the 1920s. On the South Island, they held on for longer, particularly in rugged and less accessible regions where human activity was reduced and forests remained more intact. Fiordland became one of their last major refuges, a landscape of steep terrain and dense vegetation that offered some temporary protection. But even there, the decline continued. By the 1940s, Kākāpō had largely disappeared from the South Island as well, leaving only a small and increasingly fragile population on Stewart Island. For a long time, that final refuge held, but it was not secure. Predators were still present, and the same pressures that had driven declines elsewhere continued to operate, reducing numbers further and isolating individuals across the landscape. The range did not just shrink, it collapsed inward, retreating to the last places where the old rules still held, however briefly. What had once been a widespread and abundant species had, within a relatively short span of time, been reduced to a small or scattered remnant. By the 1990s, only a few dozen individuals remained. At that point, the trajectory was no longer uncertain. Without intervention, the Kākāpō was not going to recover, because the environment that had shaped it no longer existed. The Kākāpō did not recover on its own. By the time its decline had reached its lowest point, the processes that had driven it there were still in place, and the remaining population was too small, too fragmented, and too constrained to reverse the trend. What followed was not a natural recovery, it was an intervention. Early attempts to protect the species were made before its situation was fully understood. In 1891, Resolution Island in Fiordland was set aside as a nature reserve, and over the following years, more than 200 Kākāpō were moved there, in the hope that isolation would provide protection. For a time, it seemed promising, but the island didn't remain isolated. By 1900, Stoats had reached Resolution Island, swimming across from the mainland, and within only 6 years, the newly established Kākāpō population had been wiped out. The same pattern repeated elsewhere. In 1903, 3 Kākāpō were moved from Resolution Island to Little Barrier Island, but this was long before the cause of their decline was properly understood, and the presence of feral cats ensured that these birds were never seen again. Over the following decades, a number of similar attempts were made, but a combination of introduced predators and simple bad luck meant that none were successful. By the 1970s, it was no longer even clear whether Kākāpō still survived in the wild, or whether the species had quietly slipped into extinction, until a sighting on Stewart Island. Before 1977, most searchers had focused on their last known holdouts on the South Island, Fiordland, and other similarly remote areas. The discovery on Stewart Island changed that, and other subsequent surveys suggested that a population of perhaps 100 to 200 individuals still remained. Their survival there was likely due, in part, to the absence of stoats, which had never colonized the island. But the population was still in decline. Feral cats were estimated to be killing more than half of the remaining birds each year, a rate of predation that could not be sustained over time. At that point, the approach changed. Rather than attempting to protect the Kākāpō in place, conservation efforts shifted toward removing them from the conditions They were driving their decline, and they had learnt from their earlier failures. The remaining individuals were captured and translocated to offshore islands where predators had been eliminated. Every bird became known and individually monitored, their movements tracked, and their lives carefully managed. Breeding was no longer left entirely to chance, and survival was no longer determined solely by natural pressures. Instead, the environment itself was reshaped, predators removed, habitats controlled, and the conditions that had once allowed the Kākāpō to thrive were, in a limited and artificial way, restored. The recovery that followed was not rapid, and it was not straightforward. The remaining birds were few in number, and all traced back to a very small founding population, most of them originating from Stewart Island. Of the 65 Kākāpō that had been translocated, only 51 were still alive in 1995, and that bottleneck shaped everything that came next. While translocation could reduce predation pressure, it could not restore what had already been lost: genetic diversity. A population built from so few individuals carries limitations that are difficult to overcome, and those limitations influence reproduction, resilience, and long-term viability in ways that are not always immediately visible. The Kākāpō had been saved from extinction, but it had not been returned to its former state. Even with protection, growth was slow. Individuals were moved to a small number of carefully managed predator-free islands, where conditions could be more tightly controlled. The populations did begin to stabilize, but increases in numbers were gradual. 4 chicks in 1997, 3 in 1998, 8 in 1999. Kākāpō was still limited by the same biology that had once functioned so effectively. Breeding remained infrequent, tied to irregular environmental conditions, and each season produced only a limited number of chicks. Progress was not measured in rapid increases, but in incremental change. The year 2002 marked a turning point. An unusually strong breeding season produced 24 chicks, increasing the total population to 86, and, for the first time, demonstrating that recovery on a meaningful scale was possible. A few individuals became dozens, dozens became more, but always within a system that required constant attention. A graph of Kākāpō population over time makes this pattern clear. Every few years, the line shifts upward in noticeable steps, each increase corresponding to a particularly strong fruiting season of native trees. Between those events, growth slows or stabilizes, reflecting the reliance of reproduction on environmental conditions. Over time, intervention became more precise. Breeding was closely monitored, eggs were sometimes artificially incubated, and chicks were hand-reared when necessary to improve survival rates. Genetic management also became increasingly important, with efforts made to maintain as much diversity as possible within the limits of the population, ensuring that no single lineage became disproportionately dominant. This was no longer simply conservation. It was active population management, a continuous adjustment of conditions where successes depend not just on protecting the birds, but on understanding the constraints they carried with them. And slowly, those efforts began to accumulate. Numbers increased, not dramatically and not consistently year to year, but enough to shift the trajectory. For the first time in decades, the Kākāpō were no longer in immediate decline. But recovery remained fragile, because the system supporting it was still dependent on intervention, and the underlying vulnerabilities, small population size, limited genetic diversity, and infrequent reproduction, had not disappeared. They had only been managed. Today, the Kākāpō is no longer on the edge of immediate extinction, but it remains one of the rarest birds in the world, and its recovery, while measurable, is still ongoing. In 2026, the species experienced its largest breeding season on record, with more than 100 chicks produced in a single year. For a population numbering only 236 adults, this represents a significant increase, one that could shape the trajectory of the species for decades to come. Even so, this success reflects the same underlying pattern. Breeding did not occur at random. It was triggered by favorable environmental conditions, particularly a strong fruiting event, and supported by intensive management to maximize survival. The system worked, but it worked under very specific circumstances. At the same time, efforts are underway to expand what recovery might look like in the future. One long-term goal is the removal of predators from larger landscapes, including Stewart Island, where the final wild population once persisted. If successful, this could allow Kākāpō to return to an environment closer to their historical range, and potentially re-establish a population beyond the small network of offshore islands they currently occupy. Elsewhere, controlled reintroductions are being trialled within fenced, predator-free sanctuaries on the mainland. Several male Kākāpō were released into Sanctuary Mountain Mongatatari in 2023 to assess whether this approach could be viable. As the first Kākāpō living on the mainland since the 1970s, this represents a significant milestone. The project is not without its challenges. The birds have proven adept escape artists, capable of climbing fences that exclude cats and rats, and have had to be retrieved after leaving the sanctuary. But this trial represents a different approach. Smaller, more contained environments where conditions can be tightly managed, while still allowing the species to exist outside of island refuges. Each of these efforts reflects the same underlying challenge: how to move from a system defined by constant intervention to one capable of sustaining itself. Because the Kākāpō today exists within a carefully maintained balance. Predators are excluded, breeding is supported, individuals are monitored, and outcomes are managed as far as possible. It is a system that works, but it is also a system that needs to be sustained. Alongside these challenges, something else has happened. The Kākāpō, once a largely unseen and poorly understood species, has become unusually visible, not just to scientists and conservationists, but to the public, both within New Zealand and well beyond it. For much of its history, the Kākāpō was rarely encountered. Nocturnal, ground-dwelling, and living in remote forested environments, it existed largely outside of public awareness. Today, that has changed. Cameras monitor nests, individuals are tracked and named, breeding seasons are followed in real time, with footage shared far beyond the islands where the birds themselves live. Some individual moments have played an outsized role in this shift. Sirocco, a hand-reared male, became internationally known after an attempted mating with BBC wildlife presenter Mark Carwadine was broadcast widely.
In one thing.
Oh, look at that.
Ow. God, he's got sharp claws.
What might once have been an obscure behavioural anecdote instead became a point of global attention, briefly turning the Kākāpō into an internet phenomenon. More recently, live-streamed nest cameras have allowed people to watch chicks hatch and develop over the course of an entire breeding season, creating a level of familiarity that few wild birds ever achieve. This visibility has made the Kākāpō unusually endearing, but it has also changed the relationship between the species and the people managing its recovery. The Kākāpō is no longer just an endangered bird. It is a species with an audience. That attention brings benefits, public support, funding, political will, but it also reflects something deeper. The Kākāpō now survives within a system where its continued existence is closely observed, carefully managed, and widely shared. It is no longer hidden, and it cannot return to being so. The question now is not whether the Kākāpō can survive under these conditions. It clearly can. The question is whether those conditions can be expanded, restored, or replaced by something more stable, something that does not require such constant intervention, because the Kākāpō is no longer just a species in recovery. It is a test case for whether a system that has been lost can ever be rebuilt, and if it can, what that rebuild truly looks like. I hope you enjoyed this journey into the Kākāpō. If you're interested in the research behind this episode, you can find a document with image credits and sources in the description below. These videos take a great deal of time and research to produce. They will always remain free to watch. But if you would like to support the channel and gain access to new videos a little earlier, you can find a link to my Patreon below as well. And to everyone who already supports the channel, thank you. Your support genuinely helps make these videos possible. If this video sparked your curiosity, don't let it stop here. Share it, talk about it, and keep learning. There's still so much to discover about the world's rare and remarkable species. And the more we understand, the better our chances of protecting them. Thanks for watching.